Hello, today we're going to talk about task 7.2, which is basically talking about that segments have length, and because they have length we can measure them and then you can do some mathematical operations with them. So we're going to discuss that today. So first, I'm going to skip this one. I'm going to move down to the bottom. First we have this segment CT, right? So if we wanted to name the segment, we talked about this in task 7.1. When you name a segment, you put the two letters, the endpoints, and you put a bar overhead. Or another way to name it could be segment TC. Remember, I just want to refresh your memory, we say segment CT or TC depending on which way you wrote. So if you read this to me, remember we translate it. Now describe the length. That's the measurement of the segment. It says here it is 65 inches. Okay, so most segments have a length. Sometimes they're given, sometimes they're not. So if we go to the next page, the segment addition postulate states that since we can use segments to model real-life scenarios like distances and lengths, we are often interested in measuring how long a segment is. As long as B is between A and C, we can say the following. This first segment is segment AB. Segment AB. The second segment is segment BC. Segment BC. We talked about this the other day that actually you can put the segments together and make this big, large segment. And that segment is AC. Because because point P is between A and C, we can add the two smaller segments to get the larger segment. So we can say, these are the three segments. When we're talking about the segments, we use the bar. When we talk about the measurement, then we do not use the bar. And so the way I would write this segment addition postulate is that segment AB plus segment BC equals segment AC. You can't really see the blue too well. Let me try to write this in brown real quick. Sorry, I just want to make sure it's clear on the video. That's the whole thing. Notice when I'm discussing the segments or talking about the segments, I use the bar. When measuring, there is no bar. So if there is no bar above the segment, that's how we know we're talking about the measurement. All right, so let's do a couple examples here. For number one, I want you to find the length of segment PR. A lot of times it helps to highlight what you're looking for. We're looking for the whole thing. And so if we want to do the whole thing, we need to do the two segments. So we need segment PR. That equals segment PM plus segment MR, the two segments together. Well, I know that segment PM is 8.5 and segment MR is 4.2. So PR equals 8.5 plus 4.2, which is 12.7. So the answer to the question is find PR is 12.7. We would like you to write the words or to write the equation using the letters you're going to use first and then replacing them with numbers. And this is a good example why. If we look at number 2, there's three segments. Segment AB, let's do this again, segment BC and segment AC. So we know if we start it again, the whole segment, segment AC equals segment AB plus segment BC. Now, if we fill in the associated numbers, AC is the whole thing, and that is equal to 54. AB was 25, and BC was what we don't know. And in math, when we don't know what something is, that's what we call X. We label it as X. That's what we do a lot, right? So now in order to find X, I have to solve this equation, and the way I'm going to solve it is I'm going to subtract 25 from both sides, And there's my answer. X, which is now my BC, x equals 54 minus 25, which is 29. So the length of BC is 29. Notice here again, I just want to point this out that for numbers 1 and 2, do you notice how there's no bar over these? That's because we're talking about length or the measurement, so there you won't see the bar there. One other thing I want to teach you, we're going to go on to the next page, is about midpoints. Suppose you want to cut a rope in half. How big should each piece of the rope be? Well, a midpoint is a point that is exactly in the middle of a segment. So if I were to cut this in half, and this was 30 inches, each piece would be 30. You could multiply by 1/2 or divide by 2, would be 15 inches. So each half would be 15 inches. They have to be the same. Okay, so the definition of a midpoint, just to refresh, is a midpoint is a point that is exactly in the middle of the segment. When two segments are the same size, we say that we use this new geometry term called congruent. The word is congruent. The symbol for congruent is this. It's an equal sign with this little squiggle on the top. That is the symbol for congruent. And then on the diagram, we use tick marks to show that they are congruent. So tick marks might look like this. Because they have the same tick marks, we know they are congruent. If I had this same segment, HJK, and I have this, now these have tick marks, but they're not the same, so this would be not congruent. These two segments are congruent, so the tick marks have to match in order to indicate congruency. To go over to the definition of bisect, a segment is bisected when it is divided into two congruent sections. So bisect is just another word to say exactly cut in half. Line AB bisects HK. Now it's really important. HK is what is being bisected. This is segment HK. HK is bisected, therefore these two segments are congruent because it's cut exactly in half. And so to write the congruency statement, this first segment here is HJ. So segment HJ is congruent to segment JK. That's how we write it. Notice how I went back to putting the symbols here, the line over the segments. In the previous page, we didn't because we were talking about measurements. Now we're just talking about the segments in general, and we do not use, or we use the bar here where we didn't in the other case. So if I go to number 1, M is the midpoint of AB. Use the diagram to find the measure of AB. So M is the midpoint of, this is line segment AB. That's what we say. I'm going to put it in quotes to find, and this is the measure of AB. That's the difference. That's the difference between the bar and not the bar. So if segment AM is 13, segment MB is congruent because you see there's these same tick marks, which means this segment is 13. Now, the question is asking, use the diagram to find the length of AB. AB is the whole thing, which is, whoops, I should have started with the letters. This one's pretty straightforward and it seems silly, but I just want you to get in the habit of it. It's going to be segment AM plus segment MB equals segment AB, which is 13 plus 13 equals 26. And that's the answer to our question. Now this next problem is a little trickier because there's an x involved. And so we need to solve for x. Whenever you are asked to solve for x, you have to set up an equation. There has to be an equal sign so that we can solve. So let's read what this says. Given B is the midpoint of segment AC. So this is the midpoint. So right away, I would say put some tick marks here to remind yourself that they're the same. They want you to find the measure of segment AB, segment BC, and segment AC, all three. First, we need to write the equation you would need to solve in order to determine the value of x, and then solve the rest of the problem. So first, we need to solve for x. We have to set up an equation. Because these are tick marks, that means they are congruent, which means they are equal. And so my equation, so I know that segment AB equals the measure of segment BC. Using the x, I can say 5x equals 3x plus 4. And now we practiced solving the other day, minus 3x from both sides, and 2x equals 4. And then we divide by 2, and x equals 2. Now that's the first part of the answer. X equals 2. But now you have to find the length of all the segments. And so how can we find the measure of segment AB? Well, we know that it's 5x, and we just found out that x equals 2. So 5 times 2 is 10. So the measure of AB is 10. Now, if you remembered that these are congruent and they must be equal, you could just write 10 there if you wanted to. If you wanted to double check, the way to double check is you would do 3x plus 4. Now we know x is 2. So 3, plug in 2 for x, plus 4. And then we have 6 plus 4 is 10. So great, we figured it out. Good job. AC is them all added together. AB plus BC equals AC, which would be 20 in this case. I don't think I need to do any more. I think I would like you to try the rest of these on your own. If you have any questions, please ask your teacher, and I hope you have a good day.